All right, welcome back, Class 2. Today we're going to go over Mathematics of Finance, just a brief introduction to time value of money. And we will then review linear programming, answer some specific questions if you have them about the homework, and make sure everybody's good to go for the quiz, which will be due next week. Your linear programming quiz, which will cover the material we covered last week, and then your Mathematics of Finance quiz, which I think should be pretty easy. Mathematics of Finance, it's just whet your appetite here for this time value of money stuff, which will cover more in corporate finance, but just get you thinking how this works. So with that, I will dive into time value of money, Mathematics of Finance. So, what do I mean when I say time value of money? So we've got two words. We've got time, we've got value.
How much is worth at a certain time?
Kind of, but that's not really what I mean. Anyone else want to take another stab, or you want to take another stab, Brandon? Time value of money. Now, it's really simple. Like, when I tell you what it is, you're going to say, oh, yeah, of course. Why do you have to use fancy terms like time value of money to describe something that simple? So, if I give you $100 today, and 6 years later, you come back and say, hey, professor, here's your $100 back. Am I going to be happy with $100 back, or am I going to want a little more than $100 back?
You want a little more.
I'm going to say time value of money. That's 6 years. It's worth more today than it was 6 years ago. And the thing we'll talk about for the most part is the interest rate. When we get to more advanced corporate finance stuff, or you get to more advanced corporate finance stuff, you'll talk about risk and say we want more than just a simple interest rate or a compound interest rate because I'm investing in this risky venture and you need to pay me more. And we'll think about how we would calculate that. But for tonight, we'll just do the formulas for simple interest, compound interest, and we'll say we know time value of money. So with that, let me put a couple of the key terms that your textbook uses on the board, and we will work with that as we study first simple interest. So, your textbook says the formula on page 227 for simple interest. What is simple interest, by the way? Anyone want to go over that definition before I put the formula up on the board and make something simple confusing? What do I mean when I say simple interest?
So just fixed interest rate, whatever, not additional time value invest.
Yes. So I loan Brandon $100, and he's going to pay 6% simple interest. How much is he going to pay each year? $6. All right, and after he's done that for 5 years, he's going to owe me 5 times 6 is 30, $130. Now, am I going to say, wait a minute, I want interest on the whole $130? I could say that, but Brandon's going to say, well, the deal was simple interest. I only have to pay you $6 forever. So, the formula for simple interest, A, which is future value, equals P, which is present value, times 1 plus RT. That's RT. 1 plus RT. T. Okay. Let's write that out. A equals future. P equals future value. P equals present value. R equals annual interest rate. Annual interest rate. And T equals number of years. Number of years. Okay. Any questions on that? So let's calculate out that example Brandon and I just worked out. 6 years of simple interest at 6%. How much is he going to owe me 6 years from now? How much?
140.
6 years, 6%. Close. The example is stuck in your head from what I said 2 minutes ago. So just think about it again. 6 years, 6% interest on $100. How much does he have to give me back 6 years from now? Sanjay?
136.
136. Exactly. Let's try another example. Actually, let's try this. Why don't you try to calculate that out in your calculators? And that same example. 6 years, 6%. And make sure that this formula works. So R is 6%. You might put in 0.06 to your calculators. T is 6. You're going to add 1 to that. And you're going to multiply that whole thing by 100. And just make sure that your calculators are not doing anything that you don't expect them to do. Is it working out, Sanjay? Okay. Take your time. So that thing need batteries. Is it solar powered? Solar powered? So good. That's good. Yeah, crunch that in there. Okay. How's the calculator work? It's good? It came out?
136.
Use this form? 136, 136. Dr. Williams, 136? All right. So, what might earn me more money than charging Brandon simple interest and is much more common than simple interest? What is it called? Compound interest. What does compound interest mean?
Interest compound interest of the value.
Yes. So after 1 year, Brandon's balance is $106, and then I take the 6% on 106. And then the next year, which is 6%, it's like $6.18 or something like that. And then I take the interest on that, and it just grows and grows and grows. Formula for that is on page 240 of your textbook, and it is, all right, A, the future value equals present value times 1 plus I, which is the interest rate per period, times N, which is the number of periods. So let's see, I equals, let's see, interest per period. Okay, and then N equals number of periods. Okay, and this I, how we can calculate that, is equal to R, which which is the annual interest rate, divided by n. So, this is easy when we talk about just annual compounding periods, but if we start talking about periods of compounding more frequent than annual, we will need to divide the annual interest rate by the number of periods. But before we get to that, let's just do an annual example so we get fluent with this. Let's take our 6%. Let's calculate that annually for 6 years. And let's compound it. Rather than the simple interest which we got last time, we got 136. Now let's compound it. And how we're going to do that is we're going to take I, which is 0.06, plus 1. We're going to multiply that to the, we're going to take that to the 6th power. This ends the number of periods. And we're going to multiply the whole thing by 100. Okay, is everybody trying that on their calculator? Is there any questions on that? I'll write it here so there's no confusion. So we're taking 1 plus 0.06, raising it to the 6th power, and we're multiplying that all by 100 equals. Okay, does anyone have the answer yet? Take your time. Okay, so the interest rate is 6%. So you're wondering why this is 0.06? Yeah, so 6% is 6 per 100. Anytime you say percent, it's per 100. So 1 per 100. So we use that as the decimal point. If I were to say 12%, it would be 0.12. So 12 for every 100, and 100 would be 1. So 1 point, we could call 1, you know, 1.00, which is just 1. We could call that 100, and we could call 12 per 100 of these. So we can represent 12% by 0.12. Similarly, we can represent 6% by 0.06. Does that make sense? All right, so we're in your calculators. You're going to take 0.06. You're going to add 1 to it, and you're going to get 1.06. And you're going to take that to the 6th power. You just need to figure out how that works on your calculator. And we can. Is anyone getting that? Are you able to get that?
I think I got it.
Oh, what do you get? What do you have the answer?
I have really long numbers. Like, I don't know.
Yeah, it looks a bit rich. Let's. I guess let's back up a minute. Why don't you all try in your calculators 5 raised to the 2nd power, 5 squared. See if you can do that. You can do that, and what do you get? 25. Can you do that? 25. Sanjay, can you get 5 raised to the 2nd power? Got 5. You got 5 squared is 25. Sheba, you get 5 squared is 25. You got that on. Are you have your cell phone?
Yeah, I'm gonna do an app. See if I can.
Or you can just use it. Okay, you can use the app, or I don't know the Samsung. I know the iPhone. It's got.
I was using the 6. I was trying to use the 6 on the XY.
It's not
Yeah, so-
scientific, right?
Yeah, so XY. Let me see that. So XY is probably. So let's do 5 XY2 equals. Yeah. So I just hit 5 XY2 and hit equals. Try that. 5 XY equals 2 equals. Yes. Okay. So, and do you have just a calculator on the Samsung? You don't need an app. Just
No, it doesn't do the square root.
on the iPhone, it's like you have to turn it a different direction. And just open up the regular Samsung calculator. Okay, now turn it the other way. Like landscape, you know what I'm saying? Yeah, see what happens. Yeah. So we could do 5, and then we could do x squared for sure. Where is that, right? 5 x squared equals 25. Now let's go 5 y to the x 2 equals 25. Yes. So you're going to like that y to the x, because it's not always going to be as simple as squared. So just try, so just try 5 squared with the y to the x. Okay, so now that we've got 5 squared equals 25, let's try the next one. 2 raised to the 3rd power should equal 8. See if you can get your calculators to say that. You got it? Okay, you got it? And Sheba, you're just going to go 2 y to the x 3 equals. Same thing for you, Dr. Rhodes. 2 y to the x 3 equals. Sanjay, you got it? You good? Brandon? Working on it?
Yeah.
Let's see what we got.
Which one are you doing?
Yeah, y to the x. So this is the one you're going to use. 2 y to the x 3.
Oh.
Yes. Yes. All right, did you say you got it? You got it. Shiva, you got it?
Yeah.
You got it? You got it? Okay. Excellent. Sanjay, you got it?
Yep.
Okay. Fantastic. We now know how to do powers. So now we're looking at the $100 I loaned Brandon for 6 years at compound interest. All right, so I'm going to say, all right, my future value, which is A, is going to be equal to 100 times 1 plus 0.06 raised to the 6th power. So the first thing I'm going to do is 1 plus 0.06. That equals 100 times 1.06 raised to the 6th. So now that you know how to do powers on your calculator, you're going to put in 1.06, raise it to the 6th power. You should get, I don't know what you'll get, 139, 1.39 or something like that. 1.41? That sounds good to me. You got 1.41? Brandon, you got 1.41? Nikki, you got it? All right. So the same way you do powers, except it's 1.06. You got Sanjay, you got it?
Okay.
Well, go back to 2 raised to the 3rd, and just get fluent with the keys there. So let's see. So 2 raised to the 3rd. Just punch that out. No, 2 to the 3rd. Get it to say 8. Yep. 2 raised to the 3rd. How are you going to do that? Oh, okay. All right. So you're cheating here. Not cheating. You've got a little quick key for one of those.
Yeah.
So let's see if we can get 2 to the 3rd without using one of those 2 keys. that's going to be one of those top numbers here. See the ones in yellow. Yeah, you see the yellow one. See how that says like x to the root. So we're looking for something that's like this. Oh, there's one here. How about this? So 2 raised to the third. Bingo, it's too easy. Okay, good. So now you're going to type in 1.06 raised to the 6th equals 1.41. Fantastic. All right, and multiply that 1.41 times 100. What do you get? 141.85. All right, so that's better than 136. And this is the formula that you will concentrate most of your effort on going forward. Everybody uses compound interest. Nobody uses simple interest. Let's try a couple examples. Let's try $350, 4% annually for 9 years. Write that down for you. 350, 4%, 9 years. All right. 350, 4% interest, 9 years. Tell me how much my $350 is going to be worth at the end of 9 years at 4% interest. $498.15. I like it. $498.15. Does anyone have a different answer? Does anyone have the same answer? Give you a minute just to get fluent with that. See if you can get your calculator to say 498.15, excuse me. How's it going, Shiva, with that calculator? Let me write this out. So we're going to take our $350. We're going to multiply it by 1 plus 0.04. And we're going to raise it to the 9th power. So the first thing you're going to do in your calculator is 1 plus 0.04, and you're going to get 1.04. And then you're going to hit that y to the x, and then you're going to punch in 9, and you're going to hit equals. And you're going to multiply that by 350, and you're going to get 498.15. You got it? Nikki, you got it? You're the one who gave us the answer to begin with. Sanjay, you got it? Brandon, you got it?
Yeah, I just did it the one.
Did it the simple interest way? All right, Dr. Williams, is that coming out on your calculator? So it's the y to the x. Yeah, and then hit y to the x. No. So clear it. Hit 1.04. x to the y, and it's 9 equals. And then multiply that by 350, and you're going to get the wrong answer. So let's go back to 2 to the third. So 2 3 equals. Okay, bingo. All right. So now we're good. So now we need clear it. 1.04. Yeah, x to the y. What do we say? 9 equals. There we go. Okay. And multiply that. You're thinking, I know what you did. You're thinking you first need to put the multiple sign first. You're thinking of the TI, the whatever the TIX got, where you put the multiple afterwards. So let's just do it again. So 1.04 e to the x to the y 9 equals, yes. Now put times 350 equals. Bingo. Bingo. Okay. So next, $100, 6% quarterly for 7 years. So let me write that down and we'll think this through together. What did I say? $100, 6% quarterly for 7 years. All right, $100. All right, 6% quarterly, 7 years. All right. So now, okay, so what do I mean by this quarterly?
Divide by 12.
Yeah, you're on the right track. Quarterly. What, can you be more specific about what that means?
3 months.
Every 4.
Yeah, every 3 months. Am I going to charge you 6% every 3 months? Not quite. I'm going to charge you 1/4 of 6% every 3 months. So I'm going to have a quarterly rate, which is going to be 6 divided by 4. All right? Yes. And under this, I think I may have written this down. Interest rate per period. M. Actually, this is M. Let me change this here. I think your textbook, I may have written this down wrong. The I, interest rate per period, is R divided by M, which is different than N. N is the number of... I'm getting confused here. So let's first work this out, and then figure out if we've got the numbers here. Correct. So, all right. So this is going to be $100 times 1 plus I. All right. So 1 plus I. So we decided 6% quarterly is 6 divided by 4. 6 or 0.06. 0.06 divided by 4, right? Now, we're going to multiply this by n periods, and it's not going to be 7 years. It's going to be more than 7, right? It's going to be, yes, 7 times 4. 21, right? 28, yes. Yes. All right. And then in terms of calculating this I, we're going to call this, we're going to introduce, I don't want to give you something different than it has in your textbook. So you all crank that out, this problem, and let me double check in your book and see how it's describing it. I think it's on page 240. I'll look in the book, you work out the problem. Yes, yeah, that's right. M. M is number of compounding periods per year. Okay. So take your time, crank that out. You have an answer? Where do you go?
151.72.
Yes, that's what I get. All right. 151.72. Who's there? You're there? Brenna's there? Nikki? Not quite? Dr. Williams? You're there? Shiva?
No.
Okay. So, just going to take a little engineering on your calculators. I think the first thing I would do is I would take 0.06 divided by 4. And that's going to give you 0.015. So add that to 1. You're going to have 1.015. And then I would raise that to the 28th, or x to the y, 28 equals, multiply that whole thing by 100. You got it? All right. Shiva?
So 0.06 divided by 4 plus 101.
Plus 1. So give it. So
1.
yeah. What do you get? What do you have on your calculator?
So that's 1.015 divided by.
No, not divided by. You'll do the
No, the y.
x to the y.
Square.
X to the y, 28 equals.
Yeah, 151.72.
Yes. So you got it, Dr. Williams? Okay, great. So that's the mathematical calculation on your calculator. Back to the thing I got confused about earlier. The I, the interest rate in this equation, that's going to be calculated by the R, which is the annual interest rate, which is given in this example, 6% quarterly, divided by M, which we'll call M, compounding periods per year. And if I tell you compounding is quarterly, you know there's going to be 4 quarters per year. And that's exactly what we did. We divided the annual interest rate, 6%, by 4. We added 1 to it. We multiplied the new number of time periods, which is 7 years, and there's 4 in each year. 4 times 7 is 28. Multiply it by 7, boom. We got 151.72. Everyone good on this example? All right. Let's try a couple more just like that. Get you feeling comfortable. Let's try $350, 4% monthly for 9 years. Yes, monthly. So $350, 4% monthly. How long did I say? 9 years? 9 years. All right, 9 years. Let's see if you can work that out. So the first thing you want to do is this 4% monthly. What is that going to make our interest rate? What's 4%? There's 12 months in a year. You're going to need to remember that you don't have just 9 periods. Now you have 9 times 12 periods. That's going to be the exponent.
Oh, it's 366.
I got something different than that. Oh yeah, 360. It's 350. You're telling me you only get $10 of interest after 9 years? That's wrong. That's wrong. What do you got, Brent?
Yeah.
Pretty good. I would do it one step at a time. Maybe you'll be able to crank that out faster when you go on the calculator. For now, I would start by 4% divided by 12.
350 now, 456?
How much again?
359.
No, you got the same. That's $9 of interest after 9 years. What kind of bank are you investing in? But you probably pushed the wrong key somewhere. Oh, the 9. The 9. It's not 9. It's 9 years. But how many months are in each year? Yes. Better, but not 501. I like 501. How much? 501?
36.
501.36 is the correct answer. All right, I think everyone understands the mechanics of it. So if you didn't quite get that in your calculator for this one, we'll move on and try one more. But I don't think I'm leaving anyone behind in terms of the theory of it. You all know how to do it. You just might need to get more fluent with the calculator. So let's try this one. Let's do the same $350 for 9 years, but let's compound daily. Daily. Let's assume 365 days a year. Daily.
4%.
4% daily? Yes. 9 years. Daily, 365 days in a year.
So 4% daily or 4% annually?
So 4% is the annual rate. You're going to compound it daily.
Daily, okay.
So, yeah, how many compounding periods are there going to be after 9 years? Tell me how many.
3,285.
Sounds right. Something like that. 365 times 9. All right, Sanjay, what do you get for the answer?
501.65.
Yes. 501.65. Anybody else get that? You got it, Brennan?
Yeah.
All right, Nikki, how close are you?
So if we calculate interest as D, we don't have to divide it by 365.
You do have to divide it by 365. So
Interest
let's,
rate also.
of course. So let's work this out. So it's 350 times 1 plus 0.04 divided by 365 times 9 times 365. So we're going to make these two adjustments. 4% divided by 365 is how much we're going to compound this every single day. And we're going to do it every day for 9 years. All right, tell me when you've got the answer, Nikki. You got it? You're going to tell me. Dr. Williams, you got the answer? Where are you at, Sheba? Well, try it. This is going to be hard getting used to your cell phone, but you understand the theory, right, Sheba? So the first thing you're going to do is 0.04 divided by 365. You're going to add 1 to that. You're going to use the x to the y button and multiply it by 3,000 whatever this comes out to, or take it to that power. And then you're going to multiply that whole thing by 350. Does that make sense to everyone? All right, so let's move on. Definitely recommend you get fluent with that in your calculators, so you can bust that out quickly as necessary throughout your MBA career and after. All right, so let's take a look at these two answers. This 501.36, that was for monthly compounding, right? $350, 4% monthly for 9 years. We got 501.36. And then when we compound daily, it's more because we're compounding it every single day. But it's not that much more, right? Just a little bit more. So compounding 30 times more per year, 365 rather than 12, we only get 32 cents extra. Apparently, mathematicians used to think that if you compound things in shorter and shorter periods, like you compound things hourly, and then every minute, and then every second, and then every split second, there was the theory that it would just go up to infinity. But they discovered that that's not the case. Because what's happening is as you are making this n up here, as you're making this bigger and bigger and bigger, you're making this I smaller and smaller and smaller. So it gets bigger for a minute, but it reaches a limit. And mathematically, what they figured out is that the limit, as n, the number of periods goes to infinity, of this 1 plus 1 over n, because as you get more and more periods, this compounding per period is going to get smaller and smaller. At the same time, the exponent is going to get bigger and bigger. It's going to equal what they call the natural logarithm of 2.7, also known as e on your calculator. You don't need to worry too much about that. All you need to worry about is the formula for continuous compounding, which is p times e, which is the natural log of 2.7, raised to the r, which is annual interest rate, times t, number of years. A equals p to the e raised to the rt. PERT, as some people who want to be funny call it. So let's take our $350. Let's compound it continuously at 4% for 9 years. And see what we get. I'm going to erase this daily, and I'm going to say continuously. Continuously. So, how are we going to do this problem on your calculator? First, you're going to need to figure out where the E is. What I'd recommend you do is you see where the E is and multiply it by 1. And if you get 2.7 and a long number, then you're on the right track. So wherever the E is on your calculator, try multiplying it by 1 and hope it comes out to 2.7. See the E. Look around for the E, see if you find the E. Yeah, those both look like the E. So do you know how to, what is it? How do you do the shift up 1? Like a shift alpha? Yeah, so try like the shift E times 1. Alright, so that didn't work. So let's do, yeah. Okay, that didn't work. How about alpha E times 1. Bingo. How would you? E. We've got e to the x. That could help us. So what if we put second e to the equals? So, 1 e to the x. Yes, okay. So try this. So it's this little e to the x, and I think a shortcut for you is multiply it to the, or take it to the first power. So you're putting e raised to the 1. So 1 second e to the x, 2.7. Or you could just plug in 2.7 in the calculator. That's a shortcut that may be good enough. E to the x. Brandon, you got an e in your calculator? Natural log?
I think so. What is this?
Yeah. You could do, what I would do is 1 e to the x. Give you your 2.7. Alright, so, 1 e to the x. That's a nice calculator for $10.
Amazon.
Oh, Amazon. Yeah, Shiva, I'd recommend you get the $10 calculator. E to the 1. If you hit equals. Yep, 2.7. You got it, you got 2.7. Okay, so now that you've got the 2.7 in your calculator, you're going to want to raise it, take it to the r times t, and in our example, r is 0.04, t is 9. So you might want to do that in your head first. What's 9 times 0.04? 0.36. Yeah. So raise it to the 0.36. See what you come up with. What do you got, Brent?
I got 501.66.
Perfect. 501.66. Does anyone have that?
We have to multiply the log 2.71 by 380 or
Raise it to 0.36.
only the log of 2.72.
Yeah, 2.7 raised to the 0.36. Then multiply that by 350. 501, you got it? All right. Sanjay? 501.11? No, that is not right. Maybe, did you just punch in 2.7?
2.71. Maybe that's what it is.
Yeah, so let's do, so just get the 2 point, how did we do the exponents on your calculator? So let's see. So we want 1 e to the x. All right, and we want xy 0.36 equals times 350. There you go. Mishiba, you're just going to need to take some time negotiating that calculator. But are you getting anything close yet? Or you understand intuitively? You're going to take this 2.7 figure, raise it to r times t. In this case, r is 0.04. T is 9. Then you're going to multiply that by 350. Try to work it out. So, okay. So actually just write it out. So, so write 2.7 raised to the 0.36. Just write it on a piece of paper. 2.7 to the 0.36. Yeah, but put a little, okay. So let's see. So, and you want 1 e to the x. That's clear. Equals? Okay, yes. Okay, so 501. So, this. So, this will actually tell us, we'll actually make it easier for us. The e to the x, e raised to the 0.36 equals, times that by the original 50 equals 501.66. We're getting that on the iPhone. That's what
No, I don't get it.
Let's see. Alright, so that's your, remember that you want to raise to the 0.36. And then we can do the x to the y. 0.36 equals, and then multiply that by 350. 5.66.
Okay.
Okay. All right. So, check it out. When we do this 4% monthly compounding, we get 501.36. When we do it daily, we get 501.65. And the absolute limit, when we compound infinitely every millisecond to infinity small, we get 501.66. Any questions just on the theory of that?
I have a question on the daily interest rate.
Yes.
I don't know how, like, when I done it with the interest divided by 365, I got complicated from.
All right, so let's back up and do the daily one more time. Daily. Daily. All right, so that's going to be, to calculate that out, we're going to have 350 times 1 plus, our interest rate is 4%, right? 0.04, but we're doing that every day, so we divide by 365, and we multiply that for 9 years, but not just 9 years, because we're doing it every day for 9 years, times 365. Does that make sense?
When I divided 0.04 divided by 365, I got as 1.095.
1.095. All right, so that's wrong, because 0.04 divided by 365 should be a really, really small number, like 0.000 something. So try it on your calculator again. Clear the calculator. 0.04 divided by 365. Let's see here.
That's how I got 1.095.
Let me see. Okay, all right. So punch it in for me. Oh, to the negative 4 times 10 to the negative 4. So that means it's 4 decimals removed. Does So you're going to have to play, so what you can do right now is say plus 1 equals, that's the right answer. It's 1.0004. So if you want to figure, if you don't want your calculator to scare you, maybe you could figure out how to change that. Or you could just leave it the way it is and realize and remember that it's the times the 10. Okay. All right. So where were we? We're talking about daily, monthly, daily, continuously. And we've got the concept. You just might need to get a little more fluent with your calculators so you can bust that out quickly on the quiz. Let's try a couple problems from your textbook. Get you started on the homework. Let's take a look at section 5.2, which is going to be on page 241. Let's look at number 20. Oh, okay. Yes, let's do that one. All right. So we're on page 241. Number 20. Brandon, do you have the textbook with you?
Yeah, I know.
Okay, that's fine. So I'll read it to you because I want you, I'll just read it to you. Shiva, you have it? Jacqueline, you have it?
Yes.
Okay. So we've got $2,550. And it's going to grow to $3,905 in 11 years. The question you need to solve is what interest rate is being used with annual compounding. So how do we get from $2,550 to $3,905 in 11 years with annual compounding? What is the interest rate being used? I just want you all to think about that for 2 minutes. Just conceptually start to think about how you're going to solve this problem, and then we will look at this on the board. Does everyone have this all written down, the formulas and stuff? Okay, so let's come back together as a class and look at number 20. We've got $2,550, and it's going to grow to $3,905 over 11 years. And we know that annual compounding is taking place. Question for you all is, what is the interest rate that is being used? How are we going to solve this problem? Anyone have any ideas?
Simple interest formula.
You're on the right track. We're going to use one of these formulas, but we're not going to use the simple interest formula because it says annual compounding.
Instead of A, then we use like A is equal to B, 1 plus R.
Well, which of these three formulas are we going to use to solve this problem?
First one, B,
You like the first one?
sorry, compound interest.
Yes, I like the compound interest. What information do we have in this?
A, B,
We've got A, we know the future value. We've got P, we know the present value. We've got 1, we know 1. And we've got N, which is 11 years. All right, so let's write out what we know. So we've got 39 equals 2550 times 1 plus I, which is unknown, and 11 years. So we just need to solve for I, right? So there's going to be one weird thing we're going to do with the exponents, which may take a little practice on the calculator, but we're not going to do that first. What's the first thing we're going to do to solve this equation?
B divided by A.
Yes, this, we're going to divide this over on this side, just like when we were solving those linear programming questions. So we're going to divide this by 255. Remember, with linear programming, to keep the equal sign equal, we need to do the same thing to both sides. 255. Okay. So what are you going to get when you divide 3905 by 2550? What do we get there? 1.53. 1.53 equals 1 plus I raised to the 11th. Now what do? We need to get rid of this. We need to get rid of this exponent, right? So we take the 11th root of this side to make it even. We take the 11th root of this side. So when we take the 11th root of this side, what happens? I'll give you a hint. This is the easy side. When we take the 11th root of this, what does that break down to?
1 plus I.
Yes, 1 plus I. We just get rid of it. We're taking it to the power of 11 inside the root sign, and then we're taking the 11th root of that. We just cancel that out. The one that requires a little bit of calculation is the 11th root of 1.53. So now is when we figure that out on your calculators. And to warm up to that, let's try a quick, let's do our 2 to the 3rd power thing again. So let's take 8, and let's take the 3rd root of that. Does everyone see this and know what I mean?
2.
Yeah, it's 2. It's 2. The 3rd root of 8 is 2. Does everyone know that? Brandon, does it make sense to you? Sanjay, makes sense to you? Dr. Williams? The 3rd root of 8 is 2. Shiva?
Yeah.
3rd root of 8 is 2. So let's see if you can get your calculators to give you the 3rd root of 8 being 2 before we go with this ugly one over here. Third root of 8 being 2?
Yeah.
All right. 3rd root of 8, 2? 3rd root of 8? Nope. You got Sanjay?
I'm not sure how to do it on this.
I think I like, okay, so what you might have to do is do 1/3 raised to the 1/3. You know how that's the same? The 3rd root of 8 is the same as. What you can do sometimes is instead of calling it the 3rd root of 8, say you're going to take 8 to the raised to the 1/3 equals 2. It's the same thing. So you may have to do that on your calculator. So, let's see. So we were doing 2 to the x 3 equals yes. Okay. So how about 2 y to the x 1 divided by. So you may need to like store it in your calculator. There's like a storage function. So you may do 1, so clear, 1 divided by 3 equals, and like store that in your calculator, like a store. And then bust out with the 8 y to the x, recall storage. Alright, I think that might be the way to do it. Definitely though, spend some time between now and next week. I'm just giving you the quick trial by fire of calculations. Spend some time between now and next week getting fluent with your calculators so you can do these problems quickly. So is everyone at the third root of 8 equals 2 on their calculator? Sheba? What do we got?
Try
So let's see. So we can do that. We can use the y to the x 1/3. So let's try this. So 8 y to the x 1 divided by 3 equals. Try it. You want to try it? Let's punch it in. So 8 y to the x 1 divided by 3. Yes. Okay. So now, instead of the third root of 8, we've got the 11th root of 1.53. Let's see if we can do that on our calculators. You got it, Brandon?
Yeah.
Say that again. What was supposed to be?
We're going to do the 11th root of 1.53. What do you got, Brandon?
I got 1.03.
Plug it back into this equation and see if it works. I'll give you a hint. I don't think it's going to work. A 1 point. What'd you get? 1.03.
Yeah.
Yeah. Okay. So that's right. But then what do you need to do to get I? This is 1.03.
So, would you minus 1 on that?
Exactly.
And then just get 0.3?
Minus 1, minus 1. Yes. And try that, Brandon, try that again. Except don't round in your calculator. Like when you... It's a blue marker, don't worry. Okay. So try that again, Brandon, but don't round this off. Don't round it off to 1.53. 3905 divided by 2550. Keep that number in your calculator. Then take the 11th root of that whole thing, store it in your calculator.
Is that 11th root?
Yes.
Yeah.
You got it?
Yeah. Okay.
Yes. So, okay, and then minus 1, which will give you your interest rate. It comes out to 3.9 something, right?
Oh.
Yes.
Oh.
39? Okay. Well, divide by 100.
Divided by 100.
Divide by 1,000, I guess.
3.94%.
You got it there? 3.9%? Excellent, excellent. Excellent. What do you got? All right, you got it too. Fantastic. Brandon's got it. Nikki, you got it? root. Okay, let's take a look. All right. Clear. All right. So let's do. See this little x root of. So we're going to use the shift. So we're going to use 8 shift 3. 8 shift 3. 8 shift. Yeah. Oh, okay. Here we go. We're going to do 3 shift that. The third root of 8 equals 2. Right? Yep. So, yes. So we're going to do 3, the third shift root of 8 equals. So then we're going to do 11 shift, yes, 1.53 equals 039 minus 1 equals, yes, times 100 equals 3.94%. You got it, Sanjay? You got it? No?
Yeah, I can't do on this calculator. Can I do it on this one?
Yeah? Yeah, you can do it. So, let's do, so I would do the y to the x. So that's the same thing we're doing before. Can you do it? Can you do 3 third root of 8 equals? No, that does not work. It's square root. So same deal here. It's it is 8 y to the x. Oh, and you can do the 1 divided by 3 here. Yeah, 1 divided by 3 equals. So you're taking the 1/3. So what you're going to do instead then is 1.53. Oh yeah, y to the x. 1 divided by 11 equals, yes. You like that?
Yep.
Okay. All right. So again, I may just have to stop here and say everyone at least conceptually understands what to do. Just needs some fluency with the calculator. Nikki?
After 1.03, how do we get minus?
Yes. All right. So this comes out to 1.039, but that's not the answer. That's 1 plus I equals 1.039. So we need to subtract 1 from both sides. Minus 1, minus 1. We take 1 off from here, we get 0.039. And we take 1 off from here, we get I. Make sense?
So what are the plus one?
Oh, this 1 plus?
Yeah.
Yeah.
1
So-
plus
1 plus I. So if I were to tell you, 1 plus 0.4
Mhm.
equals your interest rate, what's your interest rate? 0.4. So your interest rate is 1.4. I don't know if I said that right. Let me just put it over here. So we've got, let me erase this. All right, so I've got 1.039 equals 1 plus I. That's where we are. So my question to you is, what is I equal? Now we've got this equal sign, so let's just get rid of the 1, minus 1 here. In order to make both sides of the equal sign equal, we need to do the same thing here that we did over here. 1 minus here gives us 0.039. We take off the 1 here, gives us I. Does that make sense, Nikki?
Mhm.
Good start with? Okay. All right, let's move on then. Let's do a quick example from your textbook with continuous compounding. Let's take a look at number 23. 23 in your textbook. There we go. Run it. 23 in the textbook. Okay. We're going to be using this bottom formula down here. A equals P times E raised to the RT. How much?
27,410.
I get something a little different than that. Does anyone else have an answer? Number 23. You say 27,000, Nikki?
Oh, I did it for 9 years.
Yeah, that's a lot for 5 years.
Two, 3, 8, 2, 7.
Yes.
554.
23,824. You got 27? We'll call that close enough. Maybe try to keep the E in your calculator. Like put the E in your calculator and don't round it off. Just then raise that to the 0.035 times 5. What do you got, Brent? Okay, take your time. Sanjay? Interest rate.
I have
You got the answer?
23.
Huh? Yes, but the thing is, you multiply that, and that is the correct answer. You just need to remember that that's 20,000. So multiply that times 1,000. Just put times 1,000, and you'll have the correct answer. Never mind. If you put parentheses and then multiply it by 20,000, or you could just do the whole thing again and just put 20,000 instead of 20. But you had it right. You just put 20 instead of 20,000.
It's 20,000 times e to the.
Exactly. Raised to this. So I would start with the e and raise that to the. So
What
e.
do you mean? Start with
Yeah. So get e in your calculator. Like e. So put e to the x1 or something. Equals. Yeah. What did you cut the radical sign on there? So. Oh yeah. No. 1 e to the, yes. Okay. Okay. Now hit the xy, x to the y, x to the y button. And you're going and 0.035 times 5 or parentheses. You're going to want a parentheses. We already got it. Okay, now hit the equal sign. See what happens. And let's see.
calculator. Problem having.
All right. 1 and the x. Okay, and when you multiply 0.05 times 5, you get 0.175.
Yep.
All right. So x to y. 0.175 equals, and you're going to multiply that times 20,000 equals. Okay, that's right. So you're going to take one, or actually you can do just the e. So you've got the e right here, so e, and then you're going to do the x to the y. 0.175. Equals, boom, times 20,000. Bingo.
Okay, thank you.
Betcha.
2, 3, 2, 4.
Yes. Yes. Okay. We're going to have to move on here. Conceptually, you've got it. You just need to practice with your calculator. Moving on to, let's take a look at number 35. Number 35 in your textbook. This is asking you to find the present value given the future amount. So, if you are given A, what is the present value? Now we're going to be using this formula. Given A, what is the present value? Alright, in this 35, it's 12,000 at 5%, compounded for 6 years. So, it is now worth 12,000, and we know that it has been compounded for 6 years at 5%. Alright. So we fill in what we know, and we solve for what we don't know. Make sense? 12,000 equals P, which we don't have, times 1 plus, is it 5%? Is that right?
Okay. Yes.
It's 5% teacher. 0.05 raised to the 6th. Solve for P. Just going to take some frustration with that calculator. And we can get it. Actually, no, it's not going to be too bad. Right? Because what we're going to do, all we're going to do is take 1.05, raise it to the 6th power. That's the first thing we're going to do. P times, what do you get when you take 1.05 raised to the 6th? How much?
1.34.
Times 1.34. Do we agree? Alrighty. So now all we have to do is 12,000 divided by 1.34. We divide both sides by 1.34. This cancels. 12,000 divided by 1.34 is our answer. And what do we get when we do that? 8,955 and some change. What does the textbook say? Yes. Yes, that's the correct answer. Make sense? Shiva? Does that make sense how you would do that? I know you're getting to know your calculator, but if you have to do this during the homework or on the quiz, you would just plug in what you know to the formula, crank out the actual answer. Okay. Fantastic. Let's move on to the last new concept for the night, which is annual percentage yield, APY. Question, Nikki, before we move on? Right? All right, remember we talked about different examples of compounding periods. We said 4% compounded annually, and then we said, well, how about 4% compounded daily? And then how about 4% compounded continuously? So when you're hearing all these different rates offered, one bank says 12% compounded monthly, the other says 11% compounded daily. Which is better? Well, we can calculate that by computing the annual percentage yield, which puts everything in an annualized rate. And there's a formula for that. Let me go ahead and write that out, and then we'll do a couple examples of working it out. Erase this, get this out of or sorry. If I need to redo that, I can. No problem. Let's do the APY formula. APY formula is APY equals 1 plus R divided by M raised to the M minus 1. That's what it is. APY. APY.
Is it raised to the N or the M?
M as in Mary. Here's the M as in Mary. Because the thing the annual percentage yield tells us is if one person is using 4 compounding periods and the other bank is using 12 compounded periods, we're looking at M as the compounding periods, and we're putting it all on an equal annual scale. 1 plus R, the interest rate they say they're giving us on an annual basis, divided by the number of compounding periods, raised to the number of compounding periods, minus 1. Just looks like numbers right now until we do an example, and it comes out to something understandable.
And also the number of periods.
Yes, number of compounding periods per year. Not total compounding periods, per year. All right, let's take a look at number 31 in our textbook. Find the APY with the corresponding given nominal rates. 4% compounded semi-annually. Okay, so let's see, 4%. Semi-annually. And semi-annually means twice a year. 2 compounding periods per year. So let's put that in our APY formula. We're going to have 1 plus R, which is 0.04, divided by M, which is compounding periods per year, which is 2, times raised to the second power minus 1. All right, so in your calculators, you want 0.04 divided by 2, add 1, square it, multiply it by 2. anyone have an answer? 0.04. 0.04. I like it. Is there anything else to it though? I want more numbers. Because what you gave me is 4%, right? You just gave me 4%.
I minus 1. Altogether I got 1.04. Can I minus?
Well, alright, so all you're giving me is, so you're telling me 4%. So that's 4%. And I can tell you that if 4% compounded semi-annually, it's going to be a little bit bigger than 4%. That may not be obvious to you yet because this is your first time working it out. The only thing you did wrong is you didn't round to enough digits, I think. Does anyone have an answer?
0.62.
1.6?
4.
4.62%? 4.62%. Right now, I'm a little more inclined to believe that is the right answer, but, because it's higher than 4%, but I get 4.04%, which means 0.0404. That's what you got?
Yeah, 0.0404.
Okay. Yes. So the correct answer is 4.04%. Or, if you see it on your calculator, 0.0404. Alright, Nick, you want to crunch that out again? See if it works. So 0.04 divided by 2. Add 1. Square it. Minus 1. Sanjay? You got it? Yes. Shiva?
1.02.
0.02. Alright. Let's look. Let's look at your calculator. So, I'm punching in some things correctly. You're gonna have to get a calculator. This is gonna be a nightmare for you. But you that as a may, 0.04 divided by 2 equals plus 1 equals. Alright, and we want to square that. So we could do our y to the x. 2 equals minus 1
right?
equals. Thank you. Got it? Excellent, excellent. Okay, fantastic. Let's take a couple minutes to break, refresh the minds, and it is 8:08 now. Let's come back at 8:20, and we're going to review linear programming. Now, if you feel like you're good on linear programming and want to go home, that's okay with me. But we'll be here, and I'll stay as long as anyone needs to go over some of the homework or go over some of the examples for class yesterday. And we'll start that at 8:20. I'm going to look at... Oh, you had a question? The continuous compounding one?
So the one right there.
Oh, the one right here? All right, let's do it. Okay. So 0.04 divided by 2 equals, all right, plus 1 equals, and we're going to square it. Raised to the 2 equals. See, we've got the right answer already. Just clarity, we're going to subtract 1.
I did a square.
Wait, and don't touch anything. We can actually multiply this by 100, and that will give us a more exact. If there were decimals beyond that,
Oh, okay.
then that would have. Awesome, thank you for bringing this. So, did you spend any time working on this? Working on this one?
Not in this one, but I did like little programs, examples, and
Oh, and this thing. So this is the whole.
binder version. I thought it's a Lucid, but it's a binder version.
It's just a binder version. It's just this. It's just the textbook in a
Yes.
binder. And you're going to keep this for future classes?
Yes, I bought it, but I don't want to read it because I wanted to practice
Okay. And this is, I thought it was so thin when they offered it to me in the text in the store. And then it said the binder version. So, but this is everything you will need for the 601 class, and it's the exact same thing as the hardcover book that I've got. It just looks like it's cheaper. Yeah, it's like $150 rather than $400.
Yeah, it's 140 something. I got it from Dropsify Library.
Fantastic. Yeah, this is good. This is the same one, the exact same one I was using. It's a good textbook. When are you taking 601?
I'm taking in the next quarter.
Okay. Next quarter. Good.
If that is the next quarter, so then I can take it.
Okay, fantastic. Fantastic. Thank you for bringing this in. I appreciate it. I was a little confused how that worked. All right.
Okay, Professor.
Yes.
She said this. She was angry. She said you need to jot down something saying I was attending classes.
Is she there now?
No, she left, but I'm gonna
Okay.
email it to her, or if you wanna do it, I will let her. But she said it needs to say that I attended since the first day of class. 'Cause, she said it has to be clear.
Thank you, reporter. She has informed me she accidentally drove. Please add her back. Thank you. Zach Williams. Phone number 07013414. I remember I accidentally dropped a class in college once. I tried to ask the professor. He's like, "Well, I have a waiting list." He eventually let me back in.
Cool.
It was annoying.
Thank you, Professor.
Yeah, you bet.
I'm running home.
Oh,
Work
okay.
tonight.
Sounds good. Just do one of two things: either get a $10 calculator on Amazon, or just practice a little bit.
And what's
That-
your basic calculator?
Scientific. I just started
Scientific.
yesterday.
Which one is it?
It's called scientific computing.
Scientific. Okay, thank you. Maybe
Okay.
I can pick one up now from Staples or something, right?
Yeah. Fantastic.
This one.
Let me just screenshot this.
Hmm?
Thank you.
I need to again show you the one last.
How much you pay for yours?
$10.
How much? Same thing? Okay. Thank you so much.
No problem.
Have a good night. I'm out.
Sure. Yeah, because 1.0 to the other one, and you're going to square it, you're going to get this, which is 1.0404. Set your minus on 1. There you go.
You were the one with the financial accounting last quarter. It was for long.
Yes.
Because I saw your comments.
Yeah.
The difference.
Yeah. Yeah.
I saw your name. Like accounting, financial accounting.
Yeah. I was in that class. It's funny because and then there's a couple of kids because I'm taking corporate finance also on Thursdays at Dodge Bay, and there's a bunch of kids that were in that class that are in that class.
Oh,
Also.
okay. How was that? Corporate finance.
Yeah, you were right about Ron. I mean, he's a stickler about how he wants his things done. But
Yeah.
I mean, he seems like I'll learn a lot. So the class isn't that boring. So, but it compiles with stuff for this class. So it's kind of good that I'm taking this and then the next day I go to that one. So it goes hand in hand.
I was also there on Thursday, opposite to your class. I took the business economics
Mhm. Yeah.
A lot of case studies.
Oh yeah, like I told you,
Yeah.
that class is it's pretty much mostly case studies, and you're gonna have to write 3 papers.
Yeah.
So, 2 research papers, and then you get a final. They usually give you a topic for the final research paper.
This professor only give one research paper.
Oh, yes.
Yeah.
Oh wow, that's even better. 'Cause-
And one case study he gave on the president. Like we have to pick any president and we have to write up 15 pages.
That's- I would have rather did that than what I had to do the online one because it was like, because it was 2 case studies. We had 3 case studies because it was 2 weeks apart. First you write answer the questions, and then you write a summary the next week that's due.
Yeah.
And then with the questions, you had to write the post on the discussion board. You needed a minimum of 10,
Oh,
which I thought was ridiculous.
so this professor he don't do anything online or he don't do post. Everything is from the book. Every 9 chapters, so there is 9 case studies for every week from the book. So just answer the questions.
Professor, so the quizzes due before the next class, right?
Yes.
Okay.
Yes. You taking off?
Yeah.
Sounds good. I think you had a pretty good handle over things.
Yeah, because I was telling her I'm taking corporate finance on Thursdays also. So, and with Professor Ron, so he asked me who I was taking for this one, and then I said it's good because they're both going hand in hand. So I
Okay.
got you before I go deal with him.
Oh, great.
So.
Yeah. You'll need this for corporate finance.
Yeah. Because like some of the terms you were saying earlier tonight, I remember at the first class last week, so it was my training, so it was all clicking.
Right.
Yeah. I'll see you next Wednesday.
Okay. That's
Take
it.
care.
Nikki, if you just wanted, we could just get started, and we could do them right at your desk.
Sure. Yeah.
I guess I'll bring the video up here
It was
in case
just,
anybody
I
wants
watched
to
the
watch.
video like 2 times.
Okay.
I was reviewing this 3 kind of problem in this linear programming.
Okay.
13, 15, and 18.
Okay. Let's check it out.
So in this question,
Okay. Mike May has been told that each day he needs at least 16 units of vitamin A, at least 5 units of vitamin B1, and at least 20 units of vitamin C. So at least sounds like a constraint, right?
yes.
Each pill contains 8 units of vitamin A, 10 units of vitamin B, 2 units of M, while each X pill contains this much. Okay, so that's how much they contain. Cost. X costs 15 cents, gram Z costs 30 cents. How much of each of the pills should he buy to minimize his daily costs? What is the minimized daily cost? Okay.
This is our objective.
Yeah, so let's put our constraints first. So we've got vitamin A, 5 units of vitamin B, 20 units of vitamin C. Okay, so we've got brand X, and we've got brand Z. So I would use X, I would just use X and Z, or X and Y, X and Y, X equals.
So I put like XY cost is $15 and 30. But what I understand, like we have 3 constraints.
Okay. So yes, we have. It looks like we have 3 constraints because he needs at least 5 units of vitamin B1, 20 units of calcium C. It says, let me get a pen. I need a pen here. Okay. All right. At least 16 units of vitamin A. Let's look at the cost function first. So how many pills of each brand should he buy to minimize his daily cost? It's been like a year since I've done this particular one. Okay. Or 13. Then he's at least 16 units of vitamin A, at least 50 units of vitamin B, 20 units of vitamin C. So X equals brand X. X. Y equals brand C. We need to think of this a different way. 5 units. Okay. So brand X pill. So let's look at brand X. And then let's look at vitamin A. Vitamin B1. And vitamin C. X. Y. So brand X pill contains 8 units of vitamin A, 1 unit of vitamin B1, 2 units of vitamin C. Okay. And brand C pill contains 2 units of vitamin A, 1 unit of vitamin B1, and 7 units of vitamin C. Alright, and we know he needs at least, alright, minimum, this is the minimum. We know he needs at least 16 of vitamin A. He needs at least 5 of vitamin B1 and at least 20 of vitamin C. So, our constraints, so we have 3 constraints, but we look at them like this.
Okay.
So we know that 8x plus 2y. Dr. Williams, we're doing number 13 on page 356, if you'd like to follow along.
356.
Yeah, page 356, number 13.
Okay.
Okay. So, that's one constraint. Must be must be greater than or equal to 16. Okay, so that's constraints. Constraints. A. Bingo. B1. All right. What's the
1x.
constraint for B1? Yep. 1x plus 1y.
Less than equal to 5.
Say again.
Greater than equal to
Greater than or equal to 5. Excellent.
and C
C.
is equal to x2, 2x plus 7y
2x plus 7y.
greater than equals to 20.
20. Okay. Fantastic. So those are our constraints. And we've got cost is what we want to minimize, right?
Mhm.
So what is our objective function? So let's see. Brand X costs 15 cents. And brand Z costs 30 cents. Okay, so how are we going to write our objective function? First, I like to say minimize cost. And cost.
X is up to 15x plus 30y.
Yeah, if we do it in cents, but I think it's easier to go 0.15x plus 0.3y. I think we're good. So we set that up,
Mhm.
and we find the corner points, and we find which one minimizes the cost. Do you want to explain to Dr. Williams how we got this far?
Yeah, sure.
All right. Why don't you come sit back here? It's easier than doing it at the board. Just pull up a chair right here. Just watching at home.
It's so helpful. Like I got stuck in while doing the equation, and I watched the video. I was doing on Saturday night. I was doing.
Okay, well, I'm
Because
glad
I-
you spent your Saturday night
Yeah.
watching the video stuff. Okay, so Mike May has been told that each day he needs at least 16 units of vitamin A, 5 units of vitamin B1, and 20 units of vitamin C. And I was telling Nikki when I heard the at least, that sounds like a constraint. All right, and we know that each brand X pill contains certain numbers of A, B1, and C, while each brand Z pill contains certain units of A, B1, and C. And we know cost. We know brand X costs 15 cents, brand Z costs 30 cents. Question is, how much of each brand should he buy in order to meet his daily needs but minimize cost? So Nikki's going to explain how we set this up with the constraints.
First, we found the constraint that vitamin E is A.
Well, tell them about the how we set up this table here first,
Okay. So brand X, which is the Y,
or the X.
brand X is equal to X, and which cost 15 cents, that is our cost, and Y is equal to brand Z, which is 30 cents. And now we set up our constraint from the book that X is selling vitamin A, which is minimum 8.
Well, no, it's not a minimum. It just tells us how much vitamin A is in brand X.
Okay.
There's 8 units of A, 1 unit of B1, 2
And
units of C.
vitamin C, and Y represent the brand C, whatever it contains in vitamin A, which contains 2 in vitamin A, B1 contains 1 unit, and vitamin C contains 7. So we found our X and Y value, and then this is the minimum requirement. It's in-
What were they supposed to take?
Yes,
Okay. 16 of
vitamin
A
vitamins
and
A,
5 of
5
B,
B1, and 20 of
20 of C.
So that's we found.
So I'll just eyeball it really quick. Like if he needed to meet his minimum allotment of vitamin A, he could take 2 of vitamin X's,
Yes,
or he could take 8
of
of vitamin brand Y, brand C. It's like that 8 bowls of regular rice, raisin bran equals 1 bowl of total. It's the same concept here. So that leaves us with how many different constraints?
So he gave it like 3 constraints we have total.
Okay, and explain how we got these.
So A is equal to, we found like 8 of A represent vitamin A. For X we have 8, so that is 8X, and 2, so it's going to be 2Y, and we need minimum 16. So 8X plus 2Y greater than equal to 16. And for vitamin B, X is having 1 and Y is having 1. So we put like 1X plus 1Y less than equal to 5. Greater than equal to 5. Because we know the constraint has 5. Same for C. Here we have like 2X and 7Y greater than equal to 20. So we put over here like 2X plus 7Y greater than equal to 20. And the cost is already given like 15 cents for the brand X and 30 cents for brand Y. So now we have to find the corner points.
And this is the objective function.
Yes.
See which minimizes
Yeah,
this.
with minimum cost.
Makes sense so far?
Mhm.
All right, so we just need to graph these three.
So we have to, we can take only x and y. We don't have to take x, y, z. That's what I get confused because I thought like it's three constraints.
Yeah, because we got the x and y here, x and y here, x and y here. And if you play the video back, you'll see me like get confused for a second,
Yeah.
and then realize, oh, we just set it up in
Yeah.
that fashion.
So because earlier in my we set up a constraint for two of them. So I need to know how can we do for three column points. How can we do?
Well, the next step is graphing.
Okay.
Do you want to do? Should we do the graph?
If you can show for one that I can try home for the other one which I
Yeah,
haven't.
absolutely.
Because the
We can
other
do-
one is also having the same constraint.
Yeah,
Number
We
18.
we can graph this one, and then we can figure out how to
Okay.
set up the constraints. So, what are you going to do to what's your first step in terms of graphing this line? This is all a line, right?
Mhm.
How do we? All right, what's the first step in terms of graphing it?
8x and 2y will go.
Remember, I showed you a trick.
Yeah,
to
like if 8 is equal to x is equal to 0, then y is equal to 2
Yep.
times. So
Yep.
0 times n is equal less than or 0. Yeah. So it's
Okay.
going to be 8 and 2.
So, you're way ahead of me. Fantastic. Okay, so if x is equal to 0, then y is equal to 8. Fantastic. And if y is equal to 0, then x is equal to 2. Fantastic. All right. What do we get here? All right. What do we get here? We get 4, right? Right?
5.
5. Yes. Sorry. 5. My bad. All right. So if x is equal to 0, y has to represent b5. If y is equal to 0, then x has to be equal to 5. Okay. Same computation here. X is equal to 0.
So this one I didn't get it. I got like it doesn't.
Yeah, that's fine.
So
What do you got?
7 2s are 14. 8.
720 divided by 7. Does it make sense? We have this is 0, so 7y equals 20, so it's a little less than 3. It's like
2.85.
all right, we'll say 2.9. Okay, and if y is equal to 0, x is equal to 10. Okay, so let me get my ruler. Low battery. All right, we have 5%. We'll just end it there. All right, for those watching at home, battery is low, so I'm going to have to end this. And if you have any questions, you can watch class 1 video.